Shall we get started? So before I proceed, I want to confirm if there are any concepts that are not clear. Wheatstone bridge புரியலையா பாவி 45 minutes சொல்லி கொடுத்தாங்க. அது மட்டும் பாரு. நாளைக்கு வீடியோ பார்த்துட்டு நாளைக்கு சொல்றேன். சரி. You also didn't attend classes today. Okay, then what is the problem? Anyways, I'm not going to solve problem based on Wheatstone bridge. Just go through the video once. I'll tell you what are the key points you're supposed to go through. Okay. First thing is Wheatstone bridge is an application of post what method. How many of you slept yesterday? Tell me. None of you switched on the video. I was talking to myself yesterday. Some punishment. Huh? So tell me, it is based on Kirchhoff's law, right? And why is it used in the first place? Why do we need a Wheatstone bridge? To find the unknown resistance. So if I give you 4 resistors, out of which 3 are known and 1 is unknown, then the 4th resistance is found using that particular circuit, right? So how do you connect it? You connect it in the form of a quadrilateral like this, so that between these two ends, between the flat ends, you will connect a battery, and between the top and the bottom end, you will connect a galvanometer. I told you what is a galvanometer. It is a sensitive device, right? After that, the battery will supply current I. That I is broken into I1 and I minus I1. And here, what is going to be the current? IG, which is called as the full scale deflection current. I told you what it is. So if this is I1, if this is IG, then how much will be the current here? Either I1, ma. IG in the bakam board. I1 minus IG will flow here. Similarly, this is I2. This is I2 towards the bottom point. And this is IG. So what will be the current that will be leaving? I2 plus IG, right? So this one and this one will get added to give back the same current I, right? After that, what you need to do is apply Kirchhoff's voltage law for this triangle, that is ABDA, and for the other triangle BCDA. You apply for 2 triangles. After that, what will you do? So when you apply it, you will have something called as IG, right? You will get 2 equations. In those 2 equations, what you need to do is substitute the value of IG as 0 for it to be called as a balanced Wheatstone bridge. So when you have the balanced Wheatstone bridge, after you substitute IG is equal to 0, you do the mathematical calculations, you will get R1 by R3 is equal to R2 by R4. So that is a condition for a balanced Wheatstone bridge. Okay. So try this out, go through the video, okay, and let me know if you have any questions. I hope you could understand the outline. Balance na galvanometer la current irukkuda. Amma. If the current through the galvanometer is 0, you say that kind of a Wheatstone bridge is balanced. That's it. Purida. So read this question and first try to draw the diagram and do it on your own. Let me see how many of you are able to think. This is a previous year question. Convert the given statement into a diagram and show it to me. You draw the diagram. See, just convert it. No, don't look at this graph. Just read the question, what they are talking about. You have a combination of three identical cells in series. Right? There are three identical cells which are in series, for which there is a graph that is drawn between the potential difference and current. All that you need to do is find what is the EMF of each cell. So what will you do here? So EMF here is E, E, and E. This is R, R, and R. Two is correct. So basically, if you observe, these three cells put together can be replaced with a cell of, it can be replaced with a cell of, sorry, can be replaced with a cell of EMF. How much? 3E and internal resistance of 3R. Okay. Now, how to solve this problem? So if I take this as A and this as B, observe. Listen to this carefully. Listen. Everybody listen. If I take this as A and this as B, what is the relation between the terminal potential difference and EMF for this cell? If I say that the current flowing here is I, V is equal to, it is going to be 3E minus I into 3R. Right? This is according to physics. But if I look at the mathematical parameter, this is going to be 0, 6 and this is going to be 1, 0. So what is going to be the slope of this line? Slope is -6. So what is going to be the relation between them? Y minus y1 is equal to m into x minus x1. This is going to be the mathematical equation, right? So what is the value of y here? It is v minus y1 is 6 is equal to m is -6 into x is I minus I1, that is 0. Am I clear till this point? Everybody? Okay. So V minus 6 will be equal to minus 6i. Right? V minus 6 is 6i, minus 6i, which implies V is equal to minus 6 minus 6i. V is equal to, sorry, plus 6 minus 6i. Let me call this as equation number 2. Okay. If I compare the first equation and second equation, left hand side is terminal potential, right hand side is a mathematical expression. So 3E minus I into 3R is the same as 6 minus I into 6. Am I right? So 6 is equal to 3E. So 3E is equal to 6 and 3R is equal to 6. So E will be 2 volt and R will be 2 ohm. Okay. Suppose the same question was asked where you need to calculate the EMF of each cell and the internal resistance. This procedure is helpful. So basically what I did is, listen to this. I wrote the first expression using the basic physics. V is equal to E minus IR. I wrote the second equation using mathematics. So I compared both the equations, I got the answer. But had the same question come in MCQ, you cannot waste this much time. Right? So what we will do is, I'll tell you what is the alternate method here. Listen. Okay. Here I have 0, 6. What is the meaning of it? When the value of current is 0, listen guys. When the value of current is 0, the potential difference is 6. Meaning that 6 is called as the EMF of that cell. Because what is EMF? EMF is a potential difference when the current flowing through the cell is 0, right? So current is 0, 6 is the EMF, but the 6 is not the EMF of each cell, but 6 is the EMF of the total combination, which is 3E. So answer is E is equal to 2 volt. You can get it in one step also. So why I did in this way is, if suppose they extend and ask you to calculate internal resistance, that time you should not go blank. I hope both the methods are clear, right? So make a note of it. Are you done writing? Okay. Keep trying this problem. Wait. See, this is 8R. What is the effective resistance between the ends of the diameter AB? Okay, this is the question. So there is a wire of resistance 8R which is bent in the form of a circle. What is the effective resistance between the ends of the diameter AB? Okay. No. One minute. What is the answer?
2 ohms, sir.
Sorry?
2 ohms.
Correct. See, basically you can take this as 4R and this is 4R. Let me explain this problem. Visualize it. See, listen. Wire of resistance 8R. Okay. It is bent in the form of a circle. And between the ends of the diameter, there is a battery that is connected. So listen to this clearly. Whenever they say or whenever they ask what are the equivalent resistance, the first point they need to mention is between which points. If I frame the same question saying that find the equivalent resistance of this network, it is meaningless. Unless I mention what are the points between which you need to find the equivalent resistance. Okay. So the meaning of between AB is there is a battery which is connected virtually. Right? There is a battery which is connected. Now, I have a question. If I take the resistance of this wire to be 8R, if I break it into 8 equal parts, what will be the resistance of each part? Sorry, each part. See, if I take this to be 8R, I break it into 8 equal parts. What is the resistance of each smaller part?
1 hour, sir.
Sorry, it is?
1 hour.
It is 1 hour. It's not 16. How will it get increased? 1 by 16 of? 7. Why? It is just 1 by 8. How many parts are you breaking? 1 by 8, no? So answer is 1 hour. Unless you know this logic, you will not be able to touch this problem. Listen to this carefully. I repeat the question. This is of resistance 8R. You break it into 8 equal parts. The resistance of each small part is going to be 1 R. But why? Very good. So R is equal to rho into L divided by A. If you look at each part, resistivity is the same because it is made of the same material. Right? What has happened to the length? The length of each part has decreased by 8 times. So it is 1 by 8. And what about the area of cross section? It is the same. So R is directly proportional to L. So R by 8 will be the resistance of, 8R by 8 will be the resistance of each part of length. Are you able to understand this? Okay. Now, when I convert it like this in the form of a circle, when I connect the battery here and here, how many parts am I breaking it into? You are breaking it into 2 equal parts. So 2 means 8R divided by 2. So it should be 4R and 4R. Now the next question is, how is that 4R and 4R connected? How are they connected? They are connected in parallel or series? Series, illa parallel. Series. KBC lo ukkara vechi enna agum? KPC lo ukkara vechi.
Series, sir.
Avunu series. This parallel. Because see, this end is there, no. This end is common for the upper part and the lower part. So they both logically per. When the current is high, that is where this current law will help. When current is high, current is to I1 and I2. Whenever there is a division of it is parallel. Because what happens in series, that is the same. So it's parallel connection. So when 4R and 4R are connected in parallel, what will be the equivalent resistance? That is answer. For me, answer is not important. Did you understand the concept? When to decide whether it is series or parallel? Will you be able to decide it next time? Yes. So what is that you're supposed to do? What test are you supposed to run? You take the current from the battery. If the current is getting divided across the resistors, they are said to be in parallel. If it is going to be the same, that's it. Clear? Shall I proceed? Solve this. Don't be in a hurry. Read the question carefully. Understand the concept and then do it. So there is a 10-volt battery. There is a 10-volt battery of negligible resistance is connected across a 200-volt battery and the resistance of 38 ohm as shown in the figure. Find the value of the current in the circuit. It's actually a very simple problem. So solve it. I have solved a similar kind of a problem already. When I explained the concept of cells in series, I explained you one important thing. I don't remember which one, but I explained you, and I explained this concept when I discussed the concept of charging a cell also. Look at the way the cells are connected and decide whether the EMFs are supposed to get added or subtracted. Look at it. When will the EMFs get added? Parallel series, I told something. Which both terminals are same? They should not be same. When unlike terminals are connected together, they get added. That's what I did in the first problem. Negative was connected to positive. Whereas in this problem, like terminals are connected together. When like terminals are connected together, the EMFs will get subtracted. You need to subtract the lower value from the higher. Obviously, what will be the answer here? See, these things I want you to solve it in mind itself. It's a very simple problem. So what is going to be the equivalent EMF here? 190. And what is going to be the resistance here? It will be 38. So what is going to be the value of I? I is equal to V by R. 190 by 38 is going to be 5 ampere. That's it. So it's a simple problem, right? See, these are the kind of MCQs you will get, which most of them claim to be tough. But is it really tough? This is how you will get. Okay.
Sir,
Tell me now.
if like ends are connected, we should subtract them. If unlike ends are connected, we should add them.
Yes. See, logic is simple. Don't remember like that. If at all you get stuck, no? Let's say after 5 chapters, you will again have this confusion. You cannot remember this. So at that time, what you do is, look at how the 10-volt battery is supplying the current. It is supplying in the anti-clockwise direction. And 200-volt is supplying it in the clockwise direction. Since the currents are in opposite direction, what will happen? They are getting opposed. So since they are getting opposed, they both are not complementing each other. They are opposing each other. That is why you need to subtract. Whereas, had the same question been like this, this is 10 volt, this is 200 volt, this is 38 ohm, and it works like this, then what should be the case? Why are you adding? Because 10 volt is also supplying current in leftward direction. 200 volt is also supplying the current in the same direction. They get added. Am I clear with this? Shall I proceed?
Okay, sir.
So 5 ampere, that's right, yes. Show the variation of resistivity of a copper as a function of temperature in graph. It's not a problem actually, it's a theory-based question. You have your textbooks. So go to page 140, I think. That's what the previous batch told. Go to page 140 and see the graph. One 141. What is it? 149. I'm sorry, Upper. The Pudu book. Okay. Okay, Upper. I'm sorry. This is page number. Sorry, 104. The 40. I told the reverse 104, sorry, my mistake. So in page number 104, you have the graph. See, it's not increasing, decreasing. Copper is what material? It's a conductor. So for a conductor, I told you one relation, rho is equal to rho naught into 1 plus alpha into delta T. What is the value of alpha? It is positive. Meaning with temperature, resistivity is supposed to increase. Had they given a semiconductor here, then it would have decreased. But it will not increase linearly, rather it will increase like this. So this is the graph which will be given. It is the first graph in that page. In page 104, you have the first graph, no? How the resistivity of a conductor changes with respect to temperature. You have it? So that's the answer. Why I asked you to open it? Remember the third graph also. Third graph is for semiconductor. Okay, you can expect this kind of a question also. Second graph is for yes, it's a resistivity of nichrome wire. Basically, it is used in heating elements. Okay, nichrome or nichrome, whatever you call it. Okay. You know about the heating effects of electric current, right? What happens when current is passed through a conductor for a longer duration, it gets heated up. So nichrome has one of the capacities to get heated up faster. Okay. Next. So this is another question. Two metallic wires of same material. So when I say same material, what comes to your mind? When I say same material, resistivity is same. Have the same length. So the length is same, but cross-sectional area are in the ratio 1:2. So A1 is to A2 is equal to 1:2. A1 is to A2 is equal to 1:2. So they are connected in series and in parallel. So how are they connected? There are two resistors. Those resistors are first connected in series, then in parallel. When you do that, compare the drift velocities of electrons in the two wires in both the cases. So if you observe, the question is related to drift velocities. So you have a relation where drift velocity is connected to current. Correct? See, first of all, we know that R is equal to rho into L divided by A. So R1 by R2 is equal to rho 1 L1 A1. Here it is rho 2 L2 by A2. So rho 1 and rho 2 are same, L1 and L2 are same. So what will you get? This implies R1 by R2 is equal to A2 by A1, which is going to be 2 by 1. R1 by R2 is equal to A2 by A1, which is going to be 2 divided by 1. Am I right? Listen. Now, we have the relation as I is equal to NEA VD, which tells you the relation between drift velocity and current. So from this, can I say VD is equal to I divided by NE into A? Right. So when I talk about series connection, VD1 divided by VD2 is equal to I1 divided by NEA1 divided by I2 divided by NEA2. So NE and NE will get cancelled. What about I1 and I2 in the case of series connection? They're same. So I1 and I2 are also going to get cancelled. So what is that you're left out with? You are left out with A2 by A1. So A2 by A1 is 2:2. So VD1 by VD2 is equal to 2 divided by 1. This is the ratio of drift velocities when they are connected in series. Okay. See, how many of you remember Bernoulli's theorem from last year? You have heard of this? இல்ல பார்த்ததே இல்லைன்றிய வாழ்க்கையில இல்ல ஞாபகமே இல்ல. சரி, ஈக்குவேஷன் ஆஃப் கண்டினியூட்டின்னு ஒன்று இருந்து ஞாபகம் இருக்கா? A1 V1 is equal to A2. ஒரு சப்பையான ஒரு ஈக்குவேஷன் இருக்கும். அது மீனிங் என்ன? You remember it? A1 V1 is equal to A2 V2. It's an application of Bernoulli's theorem, which is called as equation of continuity. ஞாபகம் இருக்கா? அந்த ஈக்குவேஷன் முக்கியம் இல்ல, அதுக்கு மீனிங் என்ன சொல்லுங்க? You have a tube like this, which is of varying cross-sectional area. Iduda area of cross-section is A1, and let's say the speed of the liquid here is V1. And the area of cross-section here is A2, and the speed is V2. So tell me, where will the liquid flow faster? Is it in the smaller area of cross-section or bigger? Smaller. What is happening actually? A1 V1 is equal to A2 V2. Can I call it as a constant? So area will be inversely proportional to velocity. Area is more, velocity is less. If you observe, same logic is working here. First one has smaller area of cross section. Second one has bigger area of cross section because 1 is to 2. Right? So what is happening to the drift velocity? Drift velocity is more for the first area and less for the second area. Are you able to understand? Sorry? 1 is to 1. 1 is to 1 is correct, but I'll tell you how. So when I take for parallel connection, when I take the parallel connection into picture, right, VD1 divided by VD2 is equal to I1 by NEA1 divided by I2 by NEA2. Cancel this and this. Right. This will be equal to I1 by I2 into A2 by A1. What happens in the case of parallel connection? V is same. So if I take V is equal to IR, so I is equal to V by R. When V is taken to be constant, can I say I is inversely proportional to R? When I is inversely proportional to R, I1 by I2 will be equal to R2 by R1 into what is A2 by A1. So observe, R2 by R1. R1 by R2 is 2 is to 1. So R2 by R1 will be 1 is to 2. So half into A2 by A1 is 2 by 1. Cancel it. Answer will be 1 is 2. I hope you could understand the logic. So when they are connected in series, parallel, the drift velocity in both the scenarios will be the same. Shall I proceed? Listen to this. Tell me. I is inversely proportional to R. So I1 by I2 will become R2 by R. Okay. I'll try to, I can't erase, but I'll see. do this. This is the derivation, right? Which derivation are we supposed to use? So we saw a sequence of derivations. Now, first was the derivation for drift velocity. Second is for the relation between current and drift velocity. So that is the thing you need to write. Sorry, this one, they're asking the resistivity of a good conductor in terms of relaxation time. So you need to basically use Ohm's law. Write the derivation of Ohm's law. In one of the steps, you will be able to get the expression for resistance. From that, take the expression for resistivity. Everything I've given in the notes, please check it. I've explained in the class.
Sir,
Ah,
sir, for this using Ohm's law, first we should find R, and then after finding R, we should divide it with L by A.
first you have illada. See, I'll tell you what you're supposed to do. You need to start with this. You will first write I is equal to NEA VD. Correct. So I will be equal to NEA into what is the value of VD? E into capital E divided by M into tau. So this will be NE square A into E divided by M into tau. But what is the value of E? It is V by L. So it is NE square A divided by M into V by L into tau. So this is the value of I. So V will be equal to ML divided by NE square A, the whole multiplied with I. So what will happen here? R, this thing is R. R is equal to M by NE square tau into L divided by A. So what is this value? This is what is resistivity, and that's the question. So resistivity is equal to M divided by NE square tau. That's what they ask in terms of relaxation time. Clear?
Sir, நான் இதான் சார் சொன்னேன்.
என்னதுரா?
சார் நீங்க பண்ணி காமிச்சீங்க, நான் இதே தான் சொன்னேன்.
ஓகே ஓகே. புரியல. இதுதான். This is what we need to do. This is what you told, it's right. V is equal to IR. That is how the derivation starts. They asked you to derive an expression for resistivity. You cannot directly write this thing and say resistivity is M divided by NE square tau. You need to start with this from here only, basically by changing the drift velocity into E into capital E by M into tau and changing the electric field into V by L only, you got that expression. That is the meaning. Okay. Right? Shall I proceed?
Okay.
So using the mathematical expression for conductivity of a material, explain how it varies with temperature for semiconductors and good conductors. Okay. Rho is equal to M divided by NE square tau. So if this is resistivity, what is conductivity? 1 by resistivity, which is conductivity, is equal to n e square tau divided by m. So for good conductor, it is easy for us to explain the conductivity. When the temperature increases, I'm only explaining for good conductors. When temperature increases, relaxation time decreases, so conductivity decreases. Correct? Temperature increases, relaxation time decreases, conductivity decreases. Whereas for semiconductors, what we can say is, see, I cannot explain in depth. For semiconductors, basically, when you write that expression, alpha value will be negative. When alpha value is negative, with the increase in temperature, resistivity will decrease. Is that point clear? Shall I proceed? The next question is, prove that the current density of a metallic conductor is directly proportional to drift speed of electrons. So you need to derive that I is equal to NeAVD. Where will you start with? From the basic definition of current. So I is equal to Q by T. So Q is equal to N into E divided by T is L divided by Vd. This is the second derivation that we saw after drift velocity. Okay. So this will be equal to Ne into Vd, the whole divided by L. So multiply with A, divide it with A, N divided by A into L is going to be small n. So small n into E into A into Vd is what is current. So bring the A to the left hand side, I divided by A will be equal to Ne into Vd. So this is going to be the expression for current density. Am I clear with this? Yes. My legs are paining. Next, The potentiometer is not there. Okay, so don't worry about it. You can try this. Calculate the equivalent resistance of the given electrical network between the points A and B. எப்படி R/3 பண்ணு எக்ஸாம்ல கேட்ட எப்படி பண்ற so here if you see they are asking between the points A and B, right? So I'll tell you how to solve. Listen, here you take point A, here you take point B. What you need to do is you need to redraw the circuit. Okay, so if I take this to be A, if there is a wire or resistor, I think there's a wire. I can't do. Okay, let's take it as a wire as well. Okay, C, D, E. Let me take this as F. So if it is a wire, then A and F are said to be at the same potential. Similarly, between B and E, B comma E is said to be at the same potential. Okay. So when I go from F to C, right, if I take this point to be C and if I take this point to be D, listen to this carefully. When I go from F to C, there is one resistor going like this. Which one is this? This one. Similarly, when I go from E to C, there is one resistor going. Okay. Similarly, when you take from E to D, there is one resistor that is going. So from E to D, there is, and from C to D, there is one resistor going. Answer R/3. Let's see. Between C to D, there is one resistor. So let me put tick for everything. F to C, there is, I put a tick, right? E to C, this one. Similarly, E to D, this one. F to D, F to D, this one. So all the resistors used, how many resistors are there? 1, 2, 3, 4, 5. All the 5 are drawn here. Purida, do you guys understand what I did? So what is the first key thing is, if 2 points are connected with the help of a wire or without any resistor between them, they both are said to be at the same potential. First point. Second, you need to redraw it in this way. Now, if you observe, this is something similar to what you learned yesterday. What is it? Wheatstone bridge. Actually, this is a balanced Wheatstone bridge. How am I able to say that? Basically, if you take the ratio of the left-hand side resistor to the right-hand side resistor at the top and LHS and the RHS at the bottom, if they come out to be the same value, then it is said to be a balanced Wheatstone bridge. When it is a balanced Wheatstone bridge, the current through this is 0. So when the current through this resistor is 0, then the new circuit will look like R, 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 and R. And here you have A, and here you have B. These two are in. These two are in. 2R and 2R are in. Answer. That's one. That's why I'm trying to teach you the logic, not the shortcuts. Okay, ஒரு 10 problem பண்ணதுக்கு அப்புறம் you remember the shortcut. அப்படி ஞாபகம் வச்சுக்கோ. So that என்ன ஆகும்னா cumulative வரும்போது you will not forget it. இப்போ இந்த சாப்டர் படிச்சதுனால ஃப்ரெஷ்ஷா இருக்கு மைண்ட்ல. ஸ்டார் டெல்டான்னு சொல்லுவாங்க அது. அது வேற. அதை கூட இப்படி ரீட்ரா பண்ண ட்ரை பண்ணி இப்போ நான் சொல்லி கொடுத்த லாஜிக் புரிஞ்சதில்ல. போயிட்டு ஒயிட் இஸ் R/3ன்றது ரிசர்ச் பண்ண போட்டோம். ஒரு 10 நிமிஷம் உட்காந்து ட்ரை பண்ண புரியட்டும். You go in depth, then only then you will understand. The concept தெரியாம பண்ணாத please. You don't ask the question of why. எது சொன்னாலும் நம்பிடுவ வாழ்க்கையில. வேணாம். Right? So I hope this is clear. You can expect this kind of a problem also, especially in your exams and all they'll ask. Okay, your school exams they'll ask. இதுல பாருங்க. Also calculate the current through CD and ACB. எங்க இருக்கு? CD and ACB. I think it is AC. CD and AC. If a 10 volt DC source is connected between A and B and the value of R is assumed to be 2 ohm. So basically this is a circuit. I drew it, no? Okay. So in this circuit, this B is not there, okay? If I take this to be R, this to be R, this to be R, and this to be R, this is B, okay? What are they asking? They're asking between the points. They're asking what is the current through CD? 0. Balance Wheatstone bridge. Current through CD is 0. So if a 10 volt source is connected between AB, so what is going to be the current through AC? AC na idana. Evlo current irukum. So what is the equivalent resistance? 2. So what is the total current supplied by the battery? I is equal to V by R, 10 by 2. How much is it? 5 ampere. So 5 ampere is going here. Out of this 5, it is getting split across these two. Since they both are of equal resistance, 2.5. Purida. So it will be 2.5 ampere in both. Simple. Are you guys able to apply the logic? See, this chapter alone, one day I want to have a practical session completely. I'll teach you how to observe things. People are working on it. I'm doing some small activities based on it. As based on each subtopic, I'll teach you how you're supposed to think. In the answer, we'll do it practically and see. Balance this circuit, I'll tell you how you're supposed to connect. So just to solve, I'm not going to teach you in depth. See this. Okay, just to show people online also. Is there no any idea what this is? This resistor. This is a breadboard. Yaar sona breadboard na? You've seen this, sir? How do you know that this is breadboard? School. Okay, this is a breadboard. Why was school use panna matanga? Assembly le ukarunga. One day le adikano orthan. Idhukku per em breadboard na, it is looking in the form of pores. Bread mela pores irukumla. Adu mari irukum. Breadboard nu solluvaanga. So what basically happens is this line is there, no? In this line, if you connect anything along the same column, everything is said to be at the same potential. What is happening? They're said to be at the same potential. Okay. So what this circuit is trying to tell us is there are basically 4 resistors of equal value. Inge 2 ohm eduthirukanga. We'll do with something else. We need not worry about this 2 ohm. All that we need is 4 resistors of equal value. So just to tell you how a resistor looks like, this is one kind of resistor. How many of you have seen this? You have seen this? Okay. Your value, see, when you buy it from the shop, it says 56 ohm. This is called as a carbon resistor. There are many types of resistor, carbon resistor, wired resistors and everything. Basically, you take a wire, idu kuda resistor nu sollalam. See, generally when we look at this, first thing that comes to our mind is it's a conductor. How can a conductor be resistor? But basically, conductor kuda resistance irukku. It is there.
Poor resistance.
Also, this is a wired resistor. This could measure panana, there will be some value available. I don't know if it is there in the revised textbook. There will be a table based on which you can looking at this, tell what is the value of the resistance. They'll give something called as color code on top of it. And the color code வச்சு கண்டுபிடிக்கலாம். So what we will do is, in the 56 ohm எடுத்துட்டு, we can connect it in this form. And when you take a multimeter, I forgot to switch this off. So in the device, this one. Okay. So this, you know what is a voltmeter, ammeter, right? You have a galvanometer. So voltmeter, ammeter are measuring devices. Galvanometer is a sensitive device. It will only tell whether current is flowing or not. It cannot measure the value. But ammeter and voltmeter can tell you what is the value. So if I can think of a digital device where everything is combined into one, you call it as a multimeter, because based on where you place the knob, it will tell you what the value is. And these are the two electrodes, positive and the negative. So what we will do is, if you connect this kind of a circuit, you keep this in ammeter reading. You keep the positive terminal here and negative terminal here. The reading here should be 0. That is when it is said to be a balanced Wheatstone bridge. அது பேலன்ஸ்டா இல்லையான்னு தெரிஞ்சுக்கிறது what test can you do? நீங்க எப்படி லாஜிக் யூஸ் பண்றீங்கன்னு பார்க்கலாம். இந்த क्वेश्चनல ஏன் பேலன்ஸ்ட்னு வருது? How did I say that it is balanced? Resistance of LHS and RHS on the top is the same as the LHS and RHS at the bottom. It's a ratio. So இதை நான் பேலன்ஸ் இல்லாம பண்ணனா what should I do? Ratio disturb பண்ணணும். So what I'll do is, I'll change any one of the resistor with some other value. At that time, if you change, for example, if you make this, if you keep everything same, if you change this to 2R, inge veche electrode veche pathina, it should not show 0. Then you will understand what is the meaning of a balanced and a not balanced Wheatstone bridge. ஒரு நாள் I will do specifically, I'll sit on practical section. Practical உங்க லேப்ல இருக்கிறத விட நான் மீட்டர் பிரிட்ஜ் எல்லாம் எடுத்து காட்ட மாட்டேன். அது useless experiments. Okay, that can be done with the help of multimeter. I'll show you how you're supposed to think, so that you will be able to solve the problems better. One day we'll sit on that. So maybe I'll see, I'll see if class time la permutation, I'll do it, or else I might call you on a weekend. So please be prepared. If you sollitan அன்னைக்கு வந்து எனக்கு வேற கிளாஸ் இருக்குன்னா சொல்லாதீங்க. When I call you, please come, because I want everybody to assemble at same time. I can't do it multiple times. சரியா? I'll do it. Clear? Those who are online, clear?
Yes, sir. Clear, sir.
Yes, sir.
Yes. Yeah. Okay, I will wind up with this.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah, ma'am. சொல்றா. அவ்வளோ பொறுமையா சொன்னேடா. சார் நான் சொல்றேன், இதை வரேன் ஒரே 0 இருக்கிற கடத்துல கனெக்ட் பண்ணுறேன்.